Uh, First to you, Game Dev Club. I'm Jess. A faculty part of an engine and a very cool template. Full disclosure, I really wanted to learn more about game engines myself, and I kind of use this as an excuse to do so. So I'm not a complete expert, but I really want to just share the research that I did. So, what is a game engine? It's very loose definition. It could be many, many things, but mostly it's just something that transforms information. So it takes the inputs in the form of assets and then compiles them into a combination of those assets that you can, probably if you're making a game would be something that you could traverse or, something that you could play. And it's not limited to games. Game engines can be used to create architectures, simulations, and more. One of my favorite game engines I'm going to be talking about in a second was actually commissioned for NASA to simulate rockets and stuff. So that was pretty cool. Ooh, start video would be cool if you could see me. There we go. So some engines allow for the creation of assets. Some only take in assets made externally, and some do a combination of the two. Most game engines will not have any sort of modeling program. You're gonna have to use something like Blender or stuff like that to create your assets. But I know, at least for Unreal Engine 4, you can create things like textures and stuff like that inside the game engine. And in older games like Source, you could actually create entire levels without anything like Blender or an external program at all. So that's pretty cool. So a game engine simplifies the creation process. That's pretty much its primary goal. It's a way to preview the creation before you have to export it or show it to other people. For instance, you probably all know the main viewing window. Every game engine seems to have one. But I mean, taking graphics class a while ago, we didn't have that, and we had to code things, compile them, and we wouldn't be able to see them until after we compiled them and have to go back and change the code. So this is a really important one that I don't know, I've been taking for granted. So a layer of abstraction so that one game can be played on multiple operating systems. This is a really important thing for a lot of game engines to have. I know that at least Unreal Engine, Unity, almost any game engine I can think of has ways to export your game to multiple operating systems without having to rewrite your code. And again, looking back at graphics, they use things like OpenGL and stuff like that to make system independent code that you can use. So that's really cool. So you don't have to spend time writing multiple versions of the same thing. And that's really all the game engines are for, is saving you time. So making programs simpler. So a lot of game engines, you don't even have to know how to program to use. Unreal Engine has a really cool node editor that I've used a lot. And I'm pretty sure that Unity has one too. You can correct me if I'm wrong. And you can basically just do drag and drop programming, which is not good if you want something more in depth or something more unique. But if it's a small game that has some, I don't know, less innovative elements, you could really make a game without doing any programming whatsoever, which overall saves time. These things here would take, I don't know, something that would take months to build and turn it into something you could build in a week. So they really speed up the creation process, and it makes it easier for people making games, as a one-person team or a smaller group and stuff like that. And we'll talk in a while about other games or 3Ks game jam. That is true. So documentation is a big thing about game engines. Some have more and some have less. I know Unreal Engine has sort of lackluster documentation, and if you're looking for tutorials or just starting out, the learning curve is steeper than Unity or other game engines. So game engines are also kind of optional. You can make games through pure programming alone, but you'd have to do things like you wouldn't be able to preview with a main viewing window. You wouldn't be able to export it to multiple operating systems. You wouldn't have any sort of graphical interfaces that replace programming or any documentation at all. So I would not recommend doing it that way. But I don't know. I've made a couple of command line games that were pretty fun, so it's possible. So what options are out there? Game engine can include other lower level engines. Most of them have a rendering engine, an audio engine, and a physics engine. The physics engine is probably my favorite. It creates things like ragdolls and things. And lower engines are sometimes good options for more simpler games. For instance, the rendering engine might be used alone if you don't need anything like audio or physics to create a game. And, it might be simpler to just use stuff like that and code in OpenGL if you wanted to for the most simplistic experience, or maybe the most control or something like that. Probably wouldn't be the most simplistic, it'd probably be the exact opposite, but still that's an option. And the most popular game engines are Unreal Engine and the Unity engine. Those will get their own slides because they are so popular and cool. And other than those two, Game Maker Studio is one that requires a lot less programming knowledge and is really good at making two-dimensional games. It was used to make things like Spelunky and some other games. It was actually the first engine I've ever used, and probably a lot of people have ever used. And it requires less programming knowledge, but is limiting, and it's not free. So if you're making a 3D game with it, it will probably be harder. If you're trying to make something especially unique, it's one of those drag and drop type of engines that would not probably be good for making an extremely unique game. You probably have to do a lot of custom stuff for that. And it's not free, and no one likes to pay for things, especially when there's such good options like Godot, another good transition. Special because it's free and open source. It's really cool. You don't have to pay for it ever. The only problem is it's new, and therefore it doesn't have things like huge community, tons of documentation. But it lets you choose your programming language, which a lot of engines we'll talk about won't let you do. Like Game Maker Studio won't let you choose your programming language. Neither will Unreal nor Unity, I believe. I think Unity is only C#. And it's not really powerful like the other engines like Unreal and Unity because, again, it's just new. So it won't have such crazy cool graphics. It won't melt your CPU or anything like that. And then CryEngine is something that I used once and immediately threw away. It's like Unity or Unreal. It's very good at graphics. It's actually really cool at graphics. That's probably what it's best known for. But it has a very small community and it has not a lot of tutorials. So if you're just starting out, maybe try some of these other before CryEngine. It's also free-ish. And as the name suggests, it was used for Far Cry and Crysis, which are some pretty cool games. And we'll talk about some more later, but those are some 3 good options you could use for now. So now we're going to talk about Unreal and Unity. Those are the big 2. So Unreal Engine is something that the only one of the 2 I've ever used. It came out in 1998 and is a little bit more popular than Unity, but not by a lot. And the fact that it's so old and has been updated for so long is a huge boon because, it has been growing its community that entire time. It's been building documentation. And if you're just starting out, that's something to look for. It has a strong focus on graphics. It's known to as like, if you're making a graphically intensive game and you only care about graphics, Unreal is probably what you want to go with. But it also excels in visual programming and other aspects. It has those really cool node editors you can use for almost anything in the game. And it, if you don't want to use those node editors, you can use C++ and write it in that. It was used to make things like Mass Effect and BioShock, which are 2 games. One of them is my all-time favorite game. That would be BioShock. Isn't that a good game? It has less tutorials and it has a very steep learning curve. So this is a big roadblock for me, at least, is it's a huge game engine. It has tons of things. It kind of it has many smaller engines inside of it, like the rendering part of it. I know you can spend, I don't know, days in learning about that and still not understand all of it. And there's something in the chat. So Hyperlight Drifter and Nuclear Throne were made using Game Maker Studio. It's, I guess I did kind of not glorify it as much as I should have. It's actually really good for making things like 2D games. And it's also a little bit more intuitive too. So Unity, I've not actually used, so maybe other people can fill in my gaps of knowledge here. But it's less free than Unreal. Unreal is free to a point where if you get really popular or if you're not an indie studio, you have to pay them royalties. Unity, though, has some sort of expert mode that you have to pay money for. So that's something to note if you want the full experience. But for people like probably us, I don't know if there are any people here who have that kind of games. I'd be impressed if there were. But for small game developers, it's basically free. Both of these are. Actually, all of these we talked about are. It has a strong focus on versatility and is a better option for making things like 2D games, mobile games, and smaller games in general. For instance, if you're trying to make something really unique, Unity might be better. Unreal is good for making generally big sweeping landscapes and stuff like that. But Unity is probably better for making things like, I don't know, mobile games especially, because those would probably have a lot less graphics requirement. And it also is used to make Cuphead, Rust, and Flappy Bird. Those are extremely different, kind of shows how versatility it has, how much versatility it has. It's really cool. Flappy Bird might not be a pride point though. It uses C Sharp, which is less fast, but some would say better to learn than C++. So that's a cool thing. So it probably doesn't even matter what language you use, but it might matter to some people. It's significantly easier to learn than Unreal. The community for Unity, which rhymes, is extremely fantastic. It has a asset store you could use for almost anything. It has forums, and usually if you're learning or if you're stuck with a bug, you would be a lot more better off in Unity than Unreal. Cool, cool. So now we're going to talk about some other engines that I've used personally. Leadworks is kind of like a training wheels engine. It was the first kind of standalone engine I've ever used. It's really good to start out with because one, it's on Steam. You can download it from Steam. It's free. It has everything right out of the box. I believe they have a professional edition for $100, but I don't think it's necessary. It has basically it's a tutorial engine. You have everything you need into the tutorials. It has some forums that are very active. It has basically a ton of example materials. And if you're looking to learn, they even have it in their logo. That's kind of where I would start if you knew nothing. Mostly because, you know, you can just download it from Steam. You don't have to go to any third parties if you have Steam already installed, which probably a lot of us do, maybe. And the only problem is it's not very robust at all. It's not used for many things other than learning. I don't know of any professional games that have been made on it. It does, however, have a lot of the same visual programming things you can use for Unity and Unreal. And, you know, all the assets you use for Leadworks can also be used for things like Unity and Unreal if you want to upgrade it to something more robust. And also Source. You have to talk about Source because that's the best game engine. So it came out in 2004. It's super old and used mostly for modding old games. I use it for making Portal 2 maps, which is a cool game, and uh, it can be used to make maps for basically any of the old Source games. It comes with a lot of documentation and tutorials because it's so old, and that might be a good thing, but those are kind of counteracted by the fact that if you're using it to work with other games, you're limited by those other games, such as if you're making a map for Portal 2, you're limited to their assets and stuff like that. How much of these games were originally proprietary and not created to be sold on the get-go? I know Unreal Engine wasn't Unreal Engine used to be proprietary, and then they made a lot of money off of Fortnite and now it's free. I think that might be the case, but I'm not certain at all, so don't quote me on that. I think Unity has been free forever though. Yeah, Unreal Engine was used to make Fortnite, and that's pretty much what they're known for. That's their big one. Okay, Unreal has been free forever, that's true. I know something happened where they became more free recently, like maybe they reduced the amount of their percentage they take for large games. Yeah, it has had many versions. I think it's older than the Source one. I think, yeah, 1998 and 2004. Yeah, so that's an interesting thing to talk about. And I wanted to talk about binary space partitioning, which is a bit of a tangent, but also, for me at least, it was really important. That's right, it was the Epic Games Store. If you release your Unreal Engine game on the Epic Games Store, you would have to pay less. So that's cool to know. So binary space partitioning. So Source games, like I said way back before, you could make them all in the same application. You didn't have to use anything like Blender or Photoshop or anything like that. You could just create these brushes on the screen using some sort of brush editor and stuff like that. And that would basically be your entire level, was basically made out of blocks. And that didn't look too good, which is why everything's transitioned to much more dynamic high poly meshes now instead of binary space partitioning. And the reason behind that is, one, it has more detail if you use things that like you made in Blender and have high poly counts and are instanceable and modular, instead of these blocks basically making a basically making a Lego house or something. So the reasoning that this was used way back when is because it was used to help games render things. Each one of these kind of different colored polygons on the floor here you see were created when you would put some sort of object in the scene. And what this would do is, when you could see one of these, it would have a big list of what to not render when you were in a certain space. And this was used to save on things like memory space back when people had to really worry about that. And the problem with that nowadays is this would be a really hard thing to code now, or not code, but performance-wise would be really bad. Because you would have this big list of polygons in your map and have to break down the geometry that the engine created into things that were basically usable in the engine. So let's see, it was used by old games, and Unreal and new engines only use it for blocking out levels now. That's right, Unreal still has this, but it's really frowned upon to use geometry in Unreal. Instead, they want you to import your own geometry. But if you're just blocking out a level and want to see how it looks, you could still use it. Or even if you just want to make a game with it, that could happen. It would just not be as good performance-wise. So this was really jarring for me going from something like Source to Unreal, because in Source you make the entire game using this. This is basically the game. This is what you use. But then when you go to Unreal, suddenly it's like it's been taken away and you don't have any of the things you use to make the game anymore, and you have to rely on things like Blender to create all of your geometry for your map. So that's a thing to keep in mind. The reason that they decided to switch to the new ones are because these things aren't good performance-wise. As you can see, just having, 6 cylinders in your map created all this crazy geometry that would have to be kind of looked at and seen what should be rendered and what shouldn't be rendered with every movement or look you made. So having things like Blender, you have more control over this, and basically it's better in every way, but it's not as fast. So it was eventually replaced with portals. This was used in things like Quake, where instead of not rendering things that you couldn't see behind these pillars, by looking at this crazy geometry, you would instead put not a portal in the terms of the game, but a portal in the terms of like a window or a door, a portal into another room. And how that would work is every time you see the portal or the passage into another room, it would render the other room in its entirety, which means that basically the user would have to create the scheme of what to render when instead of the compiler, which gave more control and a lot more better performance. And that's used now for things like Quake. I don't know if it's used in Unreal, but it might be. And you can definitely implement it yourself if you want to render things that way. So when transitioning from old games to new games, it's really hard to switch from BSP to using high poly meshes. And complex brushes, high poly meshes, they provide better detail, they're better performance-wise. The only problem is if you want to create an entire map like this, you have to do it externally. And there isn't, I think, a single modern game engine that still uses this, but I know Source and some other do. And it's been about 30 minutes. Here's all my images because I was good and cited them. And does anyone want to talk about some other game engines they know of? And maybe, hopefully some Unity people can chime in on that since I've never used it. Looks like in the chat, we have a link to the Epic Games Store story if you want to learn more about how that works. That's really cool, actually, that there are different levels of free you have with the different game engines. Some are more free than others. That's kind of interesting.
I've got some experience building games in Unity, though not, I wouldn't say I have a lot of experience, just a little bit. I've done one game jam.
Oh, cool.
I did a VR game for my first ever game development project in Unity for a game jam back last August, I want to say. I don't know if, I think I threw that in the chat at some point. But Unity was definitely interesting to work with. It was definitely easy to look at tutorials fairly well and see where I was going. I can definitely, and having tried to work with Unreal Engine 4 before, I can definitely see what it was said about how there's way less documentation and a higher learning curve for it. That said, a lot of what I was doing in my project was mostly pulling in some pre-made things and playing with how they interact, and that was about it. It was pretty easy to put some basics together to get a basic VR camera and hand tracked controls working reasonably well.
Yeah, that's a good point. If you're using the C++ side of Unreal instead of the modular part, there's like no tutorials on that compared to Unity. I guess that there are some tutorials out there. I think I linked them here. Yeah, I have these kind of links spaced throughout this on things that are pretty cool. One of my favorites was this one was about the binary space partitioning, because that was something I was really curious about why they got rid of. Like, it just seems so intuitive to just make your maps out of blocks like this. I didn't know it was so costly. Like, you can see how just putting one cylinder in the middle, one square in the middle of this room caused it to create 1, 2, 3, 4, 5 different faces. It's kind of insane. And yeah, this will be in the PowerPoint that'll be posted later. If you want to read over this yourself, it's actually kind of interesting. This is where I was talking about those portals that would happen. For instance, every time this window was in your view, would render this entire blue square and stuff like that. And that's how it would, that's how most games render things, I think.
Not anymore. Used to be like at an era where you can see like those kind of really long transition tunnels in the game when actually they are loading, stuff like that. But for like open world games, these kind of simple techniques clearly don't work well anymore. So like
Right.
now it's usually a combination of dynamic loadings and LD and also like culling, stuff like that. So more advanced techniques.
Yeah, I should probably look into that at some point if I'm trying to do some more research on engines. This is actually really cool for me because I'm trying to, I don't know, I haven't used an engine in a long time and maybe I want to use one sometime. I think I might go with Unity just because of the tutorials on that. That seemed like the clear, outstanding winner of this big PowerPoint I made. Cool. Are there any final questions or just remarks in general?
Yeah, cool presentation.
Oh, thank you. It was kind of hard to put this together. I spent some time on this. It was good because I was using it to avoid my midterm.
I have aside from my experience with Unity, I have a friend who actually, for a project in high school, built a first-person shooter engine just for fun. It was pretty simplistic, but like even seeing his code back then definitely made me appreciate more what goes into all of making that and how much it means to be able to use an engine rather than just have to build it up yourself.
Wow, a
Though
first
I've
computer engine sounds crazy hard.
yeah.
That's some achievements, yeah.
Yeah, he's working at Intel now, as far as I know. There's also another one of the things I've just seen brought up, especially concerning like creating your own engine versus using one, is generally speaking, if you create your own engine, you can get much better optimization out of it. Your game's going to run better, but that is a huge undertaking in terms of actually, it is easily going to triple or quadruple the amount of work you do on your game to have to build your own engine a lot of the time.
Usually it's very hard. If you are like amateur programmer, you build your own engine, it's likely to be slower.
Yeah, you definitely have to like know what you're doing with it, but like you can definitely get better optimization with a custom engine. It's just you really have to know what you're doing, and it will take more time to actually build it up.
Yeah, but I don't know if you are for engines like Unity and Unreal. Probably yes, you can get way better than them if you are. But for some other engines, those ones that does not have this kind of rigid framework, but that means they are way harder to use. But on the other hand, that means using those
If you can
kind of
find a
engines
specific
and not
game
have,
engine
yeah.
for the kind of game you're going to make, it's probably going to run a lot better.
Yeah, there are some like some game engines like all just game middlewares. Those are basically libraries where you can just pick the part you want to use. For stuff like Unreal is like they just have this kind of framework, and whether you want to use it or not, you are forced to use it. That's why you have some performance lost.
Right. I probably should have said sometime here that if you're trying to make a game, I wouldn't recommend making the game for the engine. So choose the right engine for the game. Like there are some themes that are better for the other engines.
Well, making engines fun, not productive, but fun.